after 1 hour that I am talking, I start to forget what I have to talk in the next hour. So anyway, how do I do these classes? As I am doing right now. I am doing in English, okay. But for Italians, I will do a summary of of the class at the beginning or at the end. In this case, at the end. Any day that we have with me on Thursday and on Friday, both of them, we will try to have a 15 minutes of discussion. So if someone of you comes with one question about the previous lesson, I will be very happy to answer. Just try to formulate one question. Not more than one, not two questions, no, one question. Okay, one question. And if you ask me, I will provide explanation in Italian, but because we have two persons here that don't know Italian, I will try to go to do the explanation in English. But if you don't understand, I will give you also the explanation in Italian, okay? For these things, I am not wearing the mask because I know that speaking in English with the mask is more difficult for you to understand, okay? And obviously you need to have, you can do any questions that you want. All the classes will be recorded. I am recording right now. And I will upload the things that you see here. Is my my YouTube page, but I am not. I will probably upload the things also on YouTube. But the main thing is Vimeo. I am uploading to Vimeo because YouTube started to put advertisement at the beginning of my classes. And even if I do short classes, you know, you have 30 seconds of advertise at the beginning, then you are looking at my class, and then in the middle they stop you with the advertisement. So I am paying with my pocket actually a Vimeo account where you are not disturbed by those advertisements. The theoretical part of the first part of the course will be mostly, I say mostly theoretical, because probably we will do an exercise also in the first part this year to make you arrive in the second part are ready to go to the very hydrological questions. And about let's say the most of the first part will be the theory. Close to Easter or after Easter, we will do instead practice. For sure, the whole May will be practicing. And what do you have to do in this practicing? You have to take a catchment and do what I did in the slide that I showed you before. Estimated the discharge at the outlet and in several positions, and doing the budget. Maybe for engineer of the territory defense, doing the discharge is the main goal, let's say. But for who do global sustainability, the main goal is actually to do the water budget, because knowing how much water there is more important on that sense. You know, so we will, if you want, we can also differentiate your work on exercise. Someone of you is coming from foreign countries. We will do the lab on Italian catchments. But if you are really interested in something which is abroad, we can think about. Because we do in Italian, in Italy, because we have most of the data and we can manage it. For the other things, we have to invent the data, or discover the data, or go to catch the data somewhere. This can be interesting, actually, very interesting, but it can be challenging, maybe too challenging in some cases because we have a very short time. But anyway, we can try. Last year and the year before that, I keep this class. I essentially we essentially ask for you to start from a digital elevation model, extract the catchment, and then doing the interpolation of the meteor forcing, and then applying the model to obtain discharges and evapotranspiration and so on. This year, my idea and the idea of my tutor is that you have any way to learn how to extract a catchment. But you will do on a standard data set that we give you. Then we see how to test you on that side. Then you choose your catchment here in Trentino, or maybe in the north of Italy, where we have already ready the data. And when you decide the catchment, you have to choose a catchment which is close in a point where we have measurement of discharge. And then we give you the separation of this. We already give you the whole catchment already done. This saves to you at least 3 weeks of work. Okay. And so you will work on our initial data set, and then we will decide what to do with that data set. The lab work is intended to be in group. As I told you to the other classes that I teach, learning to work in group is essential here. So a group of 2 or 3 people. Someone is particularly a not social guy, and but he has to stay together with someone and learn how to work together, sharing the work, sharing the workload. Group of 2 or 3 people. So 1 is not good, is acceptable but not good. 2 is okay, 3 is okay, 4 is not acceptable, okay? Now you can go to visit the catchment. If the catchment is here, is close to here, you will have also to go there, take some photos, do a field trip. You are not a geologist, you are not a doctor in forestry. They are trained to go and do field surveys. You are trained to do calculations. You should be trained to do calculation. Nevertheless, if you go there, if you study a catchment, see the catchment, make you learn immediately a lot of things. You don't have to limit to look at the catchment as it comes out from your computer. So that's also important. What is the model here? The model here will use the modeling part will use an environment which is called GeoFrame. Probably you already start to download something of it. And GeoFrame, you will learn how it is made. Some people already has a taste of it during the course of hydrology. In this year, we will use different tools, which is for the catchment hydrology, not from the point hydrology. Some of the tools, though, are the same of the course of hydrology. For instance, you see A.T. Priestley Taylor is is one of the components that you use to estimate evapotranspiration in the class of hydrology. And here, these components are connected together to build what is called a modeling solution. And actually, you can change part of these components, these figures here, and changing model for doing certain things. One of my desiderata, my wish, I would really like that you will be able at the end of this course to change the structure is called of your model, to get a structure that is particularly fit for the purposes of your work. And we'll see here is pretty complicated because this is part of the work we did on the Blue Nile. And for instance, we have this GRACE TWSE, which is use some satellite data for and SRE SM2R minus CCI, which are satellite data that we use to drive the modeling of the Blue Nile. For your case, it will be easier here. Another thing that I was never able to do in the previous two classes was to try to assess the confidence interval of the forecasting. You know, here you have a lot of uncertainty and a lot of unknowns. Your product cannot be thought as a perfect prediction. If you study quantum mechanics seems very complicated, but does very precise results, for instance, on certain wavelengths of certain answers. Very, very precise results. Here we have answers that are always uncertain. So we will try, if we are able, to assess a little bit about uncertainty. Because then from here you have to get policies. You have to decide things. And this is moving a lot of millions of dollars of euros. And this is particularly, and so you have to do the things very carefully. And in many cases, you have to do with the human lives. So, you know, it's a different things to do works for this or for this. And if you have a lot of uncertainty, you know that the solutions that you need to implement are based on uncertainties. So you have to do to take robust solutions, which I'm not telling you how to do actually, but with unreliable methods. Okay, and uncertainty is part of it. So more or less is the whole introduction of the class. Do you have questions on that? Maybe I didn't talk about the exams. The exams, obviously, more or less around Easter time, there will be a written exam with 2 or 3 questions. Maybe I wrote somewhere. It's not written here. Ah, okay, no. Okay.